Okay, so we're gonna start with video 2 for chapter 3. I assume you practiced with all those exercises after our first video. And we're gonna start with the measures of variation. So yes, we use the center tendency to estimate where is the mean or the median of our data, what is the center of our data. However, sometimes this is not enough. An example given in your book in page 145, these two different service centers, the American Service Center and the National Service Center. If you calculate the mean, the median, and the mode for those two data sets, you will find they are exactly identical. However, when you plot the histogram, as you can see, we have a totally different type of distribution. To be able to realize what differences are in this data, we need to look at the variation of this data. And one measurement is called the range. So, as you can see on the axis, on the x-axis, the repair time, the first center will take between 3 to 6 days to repair, or the 5 days to repair any equipment, computer equipment. However, the second one will take from 1 day to 7 days. So the idea of the range is you take the highest number and you subtract it from the lowest number and you will know the range of your data. So 5 minus 3, it's 2 for the first data. However, the second data, you have maybe 7 days, 7 minus 1 day sometimes, so 6. So those are two different numbers. And this is how you can compare the variation of your data. And this is one measurement, the range, which is not a lot useful, but at least give you some understanding with the spread of your data, so to speak. The other much popular way of looking at the variance of your data is by the variation of your data by calculating the variance. The variance denoted by sigma square. And how we can calculate it, we need first to get the mean. So we are going back to the example we saw last class, last video. Chris class size had 5 different class types, and class size we divided by the number, we obtained the mean. After obtaining the mean, we will be able to calculate the variance. And you calculate the variance by subtracting every value you have in your data, 60 minus the variance, 36, and you get 24. Then you get the second number, 41, minus the mean, etc. So you apply this to all your data. Then what you have to do, you have to sum up these deviation. You sum this deviation and you divide it by the number of items you have your data. And since this data is represent the population, Chris has only 5 classes. This is the total number of population. You will be dividing by the number of population. However, we will see if we don't have the total population when we are interacting with a sample variation, we will divide by the total number minus 1. So keep this in your mind every time you are working with the data that you don't have the complete population. You have the differences between calculating the variance with the sample is you're dividing by the total number of the data items you have in your data set minus 1. So we went back to the car mileage case and we calculated the sample variance. After you calculate the sample variance, you can calculate the standard deviation, which is only taking the square root of your variance. Of course, if we use the whole the first 5 cars, we will get one measurement. If we use a 50, another measurement. Again, this is a sample because we don't have the whole population. Another way to represent the sample variance to make it easier on you to calculate it manually is by using this formula. So what you do actually, you have all your data, you first you sum them all, and then you use that number, and then you use the second part of it, which is the square root, the square of every item in your data. Then what you do, you square the item and you divide it by this number. You divide it by the number of items you have here, 65 billing, for example. In that case, you divide it by the item and you subtract it from the square root of these squared items in your data set. Then you divide it on n minus 1, the total number minus 1. And this is an easy way to do it by hand or by using the calculator. Now, if you're using Excel, Excel will give you all those results as we saw in our previous example when we pulled it here. Let's see. Yes, so as you can see, as part of the descriptive statistics, is going to give you the standard deviation and the sample variance automatically. Okay, so let's go back to the first empirical rule that is known in statistics when you have a normally distributed data. The empirical rule, it provides you with some type of analysis for your data that you can predict the spread of your data if you have a normal distributed data. And it says the following: from the mean minus plus standard deviation left or right, you can really obtain about 68.26% of the whole data you have. That's very easy to be calculated. The second one, you actually, if you calculate the mean and you goes far from the mean, 2 standard deviation left and right, actually you can obtain 95.44% of your population. So by 2 standard deviation. Now, if you go by 3 standard deviation left and right from the mean, you can obtain 99.73% of the whole population. Let us see this visually. So this is your data, and let's say it, as we assume, it's normally distributed. You calculated the mean. If you want to see what the data that concentrated in 1 standard deviation to the right or to the left, this really contains 68.26% of the whole population of your data. However, if you consider the 2 standard deviation from the mean, you get 95.44%, and finally 3 standard deviation left and right, 99.73%. So if you are capable of finding almost 99.73% of the whole population in that specific area, and everything else you consider them as if outsider, this is very easy to know where any X in your data relatively to the mean is located. So this is given with example, if you remember again the car mileage. So here is our distribution, how much from the mean you go left and right with the standard deviation value. And the standard deviation is 0.79, and the mean you start with 31.56. So 31.56 plus 0.79, you get 1 standard deviation to the right minus 0.797, you go 1 standard deviation to the left. This is how you obtain it. So this is how they got those numbers over here. And that's easy way to define where a data located in your distribution. Now, in case we have skewed data, the empirical rule doesn't work anymore, because when you have skewed data left or right, really you don't have the distribution equally distributed around the mean. And there is a way to solve this problem by using another theorem, which is called Chebyshev's theorem, and it's the following. It says that the value that you consider any population that has a mean mu and standard deviation sigma, that for any value of k greater than 1, at least there are population measurement concentrated there that equal 100 multiplied by 1 minus 1 over that k you picked squared percent. So let us take a real example to understand this. Assume k equal 2, so we divide it over 1 4, and in this case we will be able to get 75% of the population concentrated on 2 standard deviations far from the mean and 2 standard deviations less than the mean. And as you can see, that is a different number than what we got with 2 standard deviation. Actually, it was the empirical rule. With 2 standard deviation, we were able to get 95.44%. So we are losing the population, but however, we don't have another way to calculate it just because the data is not perfect to use the empirical rule. Now, you should keep in mind, when do you use Chebyshev's theorem, because it's not also can be applied to any type of distribution. I would say that only you can use it when you have non-mount shape. So because if you have a bell-shaped distributed data, you go and use the empirical rule. Now, if you have 2 peaks, this is the only time I would recommend you to use it. If you have 2 peaks of your data, this is when you will use the Chebyshev theorem. However, if the data is skewed, you cannot use neither the empirical rule, neither the Chebyshev theorem, and we will see that we will have to use something called the percentiles to look at the variation of our data and predict where a variable is going to be, or where a specific data point most likely is going to be in that data. And we will see it in the next video actually. Another thing to consider, and it's very useful to use, is the z-score, and that's definitely, you remember it from your statistics. The z-score is a way that you can, what is also called standardized value. It's a way to look at your data and describe the variation in your data. And how you calculate it? For every input, you subtract the mean and you divide it by the standard deviation, so you know exactly where that x is located in your data, how far from the mean. This is a very nice example in your book in page 152. So we have 5 companies, and all of them, they have the profit margin is 10%. And they have exactly the same standard deviation, 3.4%. Now, as you see, using the z-score, you can compare those companies with each other. So as you can see, the z-score, for example, for company 2 is 0, which means that it has the same value of the mean profit, the 10%. So there is no deviation from the standard deviation. The highest profit of this companies, you will see the third company was 1.47. So it has 1.47 higher profit than any mean margin profit, which is the 10%. The minus 1.47, just the opposite. It is the least company that made the least profit among all those 5 companies. Okay, so this is a way to compare data with each other. A very interesting way. How you can explain it with the other data set we had with the exams, for example. So go back to the exams, students' exams. They had 2 exams. The first exams assumed that a student got 65 out of 100, and we know the standard deviation is 10. And in another student got in the second exam, or the same student got in the second exam 80, and the standard deviation was 5. Now, if you want to use the z-score in that case, you just need to do the following. You take his grade and subtract it from the standard deviation, and you divide it subtracted by the mean and divided by the standard deviation. So you can say this is number 2, which is the second place in this data. And for the second exam, also it's equal because you get the same value equal to the 2. Very similar. Now, another value that associated with comparison is called the coefficient of variation, and it's very useful to use it when you want to compare, for example, stock funds. And the idea here, you want to see how much there is variation in a data set from the standard deviation, how much percentage of deviation, the standard deviation from the mean of the population. So here we have 2 funds. The first fund has 10.39% and with a standard deviation equal to 16.18. So this is the mean. And then we have the second fund, Fund 2, that has 7.7% of the mean and standard deviation 13.82. So if you calculate the coefficient variation, which is just you're going to divide the standard by the mean multiplied by 100, the first fund you will get 155.73. Whereas when you calculate the second fund, you will get 179.48. And the conclusion here, you would say, there is a lot of variation in the second fund compared to the first one, so it's much riskier to buy stocks market in the Fund 2 compared to the Fund 1. So here you are measuring the risk in funds using the coefficient variation. Now, after reading this chapter, I would advise you to go ahead and solve the exercises in section 3.2 and also take the data, the ATM transaction that's available in Blackboard, and also walk your way through it and try to find the standard deviation, the variance, and the coefficient variation. In the next video, we're going to start with what we said. This is the solution for us when we have a distribution where it's neither normally distributed and it is skewed, and we don't know which of those measurements are the best fit. And we said that the percentiles can describe the data the best in those type of cases. So the video 3 will cover that section.